Math 3, Unit 2, Section F, and this goes along with Worksheet 6. This is our last section in this unit. So graphing inequalities or systems of inequalities. When you're graphing, the first thing you need to remember, or if you don't remember that I need to tell you, is that you have your boundary line. So your boundary line is the actual line. So if you were to plug an equal sign in here into these equations, that this line is your boundary line. If you have less than or greater than, it's going to be a dashed line. And if you have less than or equal to or greater than or equal to, it's a solid line. Okay? We all understand what solid and dashed are. Okay. All right, so then when you're shading, when it says less than, and so we understand that less than is like this, right? Or it could be less than or equal to. Less than, you're going to shade towards the decreasing values. So if you are looking at this graph, decreasing values, like if, let's say my line was like this, okay? Decreasing would be below, okay? If my graph was like this, decreasing would be below. If it's saying less than, sorry, okay? And if you had like a straight up and down line like this, which way do you think the decreasing values would be? Less than values? To the left. So you're always, if it says less than, you're going to shade towards your decreasing values. Where if you have greater than, you shade towards the increasing values. Okay? After you do all that, you choose a point where the graph shadings overlap and are not on the boundary lines. If you use a boundary line, it will always work. Okay? So if you use a point that's actually on your line, the shading, it will always, your equation will balance, okay? So you always are going to check a point to see where the shading overlaps to make sure that you shaded correctly, because the point should work into both of those equations. So this is why we're choosing a point. And then after you check the 2 points, you're going to highlight the area that makes a true statement for all inequalities. Okay, so we're going to just start doing some examples, and hopefully this all makes sense. Okay. So when you're graphing this, remember it's normally easiest to graph in the form y equals mx plus b. Okay, and we remember that m is our slope and b is our, good. Okay, so do you notice that this first equation is not really written in the correct order? Okay, so we want to rewrite it. So I'm going to write this as y is less than or equal to, and then I want my x to be in front, but that negative is attached to the x. So we write that as negative x plus 5. Okay, so what is my m value and what is my b value on this one? Good, negative 1 over 1, and my b is 5. Okay, so I'm going to go up 5 first. 1, 2, 3, 4, 5, and make my point. And from there we go down 1, right 1. And you can make quite a few points if you want to make sure your graph is accurate. And if you want to, get out your ruler. Now, will this be a solid or a dashed line? Solid. And again, how do we know that it's a solid line? It has the equal to sign. Very good. Okay, and then I usually always like to use a different color for my other graph. And so on this one, I have y is greater than, and it's in the correct order, so I'm going to keep it as 3x minus 4. My m on this one is 3 over 1, and my b is, good. So I go down 1, 2, 3, 4, and then from there, I'm going up 1, 2, 3, right 1, up 1, 2, 3, right 1. And I'm going to go ahead and draw my line. Now, will this one be solid or dashed? Dashed. And I know this one is dashed because, very good, there is no equal to sign. Sometimes I forget, and if you're using a pencil on your homework, you just go through and erase to make it dashed, or you can color it, you know, heavier. Okay. All right. Now, shading. We didn't do the shading originally, and you can kind of do shading whichever order you want to. But when I'm shading on this first purple line, it says that it's less than. So I don't make a lot I don't make it really dark because your answer is actually the part where the two shading parts overlap. So I just kind of make a couple lines that show that the purple line is less than. Okay, and then your red line, the red line said greater than. So which way would I shade for the greater than? Which way would be increasing when you're looking at this line right here? Is increasing going to be above or below? Above. And do you see how these give you more positives and these going down is going to end up giving you more negatives, okay? So this line graphs like this. And so do you see the spot where the two lines their shading overlaps? Okay, so we can't pick any points on our lines. You have to make sure you're picking a point that is not on your lines. I always like to pick points that are easy. Okay, one point that is always easy is the point right here, which is 0, 0. And that 0, 0 doesn't look like it's on either one of the lines, right? And so we want to make sure that it works for both equations. So when I take the points, I'm just going to write here point 0, 0, because they want us to name 2 points that are solutions to this inequality. Okay, so I want to check 0, 0 to make sure it works in both of these equations. So we get 0 is less than or equal to 0 plus 5. So we get 0 is less than or equal to 5. Is that a true statement? Yes. Okay, so it works on the first one, but I also have to make sure it works in the second equation. So we have 0 is greater than, and 3 times 0 will end up giving me 0. And so we get 0 is greater than negative 4. Is that true? Yes, it checks out. So one point that works is 0, 0. Now, are we all going to always choose the same points? No. There's going to be multiple answers, okay? What would be another point that would be easy to choose that's not on my boundary lines?
0, 1.
Yeah, you could do 0, 1. I'm going to actually, because this way I don't have to think about what I'm plugging in, I'm going to choose the point 1, 1. Because if I go here to right 1, up 1, it doesn't look like it's on, actually though. See how 1, 1 could be kind of close? Like it could be on it. It's probably a bad one to choose. So let's go ahead and do 0, 1. So point 0, 1. Okay, so we take, remember, x and y. So first equation, I would write this as 1 is less than or equal to, and there's no such thing as negative 0, so I'm just going to write 0 plus 5. Is 1 less than or equal to 5?
Yes.
Yes, so that checks. We go to our other equation here. 1 is greater than, 3 times 1 makes 3 minus 4. 1 is greater than negative 1. Does that check out? Yes. So we have the point 0, 1. Now, if one of them didn't work, then that means you probably shaded wrong. But we found 2 points that work, and so I would highlight this area and make it so that you know that the answer is these 2 lines that their shading has overlapped. Yes. Good job. Thank you. Still works. All right. Okay, any questions here? Bless you. Okay, let's go to number 2. So where will I first have the equation y is less than or equal to negative 5? So where do I go to graph that? Good. So we go down 1, 2, 3, 4, 5. And then it's going to be a horizontal line through that point, correct? And is it going to be dotted or solid? Or dashed or solid? Solid, good. So we're going to go draw this line. Okay, and this one says that y is less than or equal to negative 5. So which way will I shade? Down, good. Okay, next line. Yes.
How do you know if you shake down?
So remember up here, so anytime you have less than, which looks like this or this,
Oh, I see.
and then greater than is where you have this, when you're going to shade up.
Okay, that makes sense.
Okay, good. All right, so second line we have y is greater than x minus 4 squared minus 1. And so this is actually not a line. What is it? Parabola. Okay, so if we're graphing this parabola, what is my vertex? Very good. 4, negative 1. And then my a value on this is 1, so that we know that the graph would end up going up, right? Okay, so write 4, 1, 2, 3, 4, down 1. And even though we know going up 1 and right 1 isn't exact, we're going to go ahead and do that just to give us an idea of what the graph should look like. And this says greater than. So with the parabola, do you think greater than is going to be kind of like inside the parabola or outside the parabola? Inside. Okay. Does the shading on either one of these graphs overlap? No. So this one is no solution, because we have to find the solution where they overlap. That's where your answer is. Okay, questions before we move on? No? Okay. All right, so next one, we have two absolute value inequalities here. So starting with the first one, we have y is less than or equal to absolute value of x minus 2 plus 1. So what would be my vertex on this one? 2. Good. And then my a value on this, which works out for me to actually use, is 1 over 1. Okay, so we go right 2, up 1, plot my vertex, and from there I'm going up 1, right 1, up 1, left 1, and so on. And then we can go ahead and draw our lines. Will this line be solid or dashed? Good. Wait, did I do the parabola right? Was it solid or dashed? And I put it solid, huh? Let's go back and fix that real quick. Yes, it was supposed to be dashed. Anybody actually do it dashed like you were supposed to? Okay, so you can't really tell on mine, but I went back over it so it could look dashed. Okay. Where are we at? Here we go. So less than. Less than on this graph. Let's see here. Yes, exactly. So, and again, it's going to look kind of weird, so let's just kind of lightly, my less than's going to be like that. And let's go to the other equation now. So we have y is greater than, and should I flip this part like around at all to make it easier on myself? Yeah, so we have to make sure that that negative stays with the absolute value, okay? And so you have negative absolute value of x minus 1, and then this is plus 5. Because notice that the 5 is positive, right? So the negative's with absolute value, the 5 is positive. What is my vertex here? 1, 5. And then my a value on this one will be negative 1 over 1. So we plot this. We go right 1 and up 1, 2, 3, 4, 5. And then we're going down 1, right 1, and down 1, left 1. And then we can draw our lines. And this one will be solid or dashed. Good. Okay, and this says greater than. So that means I would be shading up, right? Actually, yeah, we're going to be shading up, like above the graph, okay? It kind of depends on whether it's going up or down and where things go. So do you see the parts where we think that they overlap? So it's on the left side of the graph, it looks like there's overlapping, and the right side of the graph, we think there's overlapping. Do we all agree with that? Now this is why we want to test points, to make sure that we actually did shade correctly. So when we choose our 2 points, we want to choose a point in each of the overlapping areas. Okay? So what would be a point over in this area that we know for sure is not on a boundary, but is where the shading overlaps? Sure, we can do -6, 0. 1, 2, 3, 4, 5, 6. I would agree. Okay, so let's do this point, -6, 0. So we'll start here with the first equation. So we'd have 0 is less than or equal to the absolute value of -6 minus 2 plus 1. And -6 minus 2 is -8, but then when it comes out of the absolute values, it becomes +8. And then 8 plus 1 is 9. Is 0 less than or equal to 9? Okay, so that point works for that equation. So we're going to use the same point in this equation. So again, we have 0 is greater than negative absolute value of -6 minus 1 plus 5. And what is -6 minus 1? But when it comes out, it becomes a +7. So I still, though, have 0 is greater than, I still have a negative. This -7 became a +7, but with the negative outside is actually -7 plus 5, and we get 0 is greater than -2. Does that work? Yes. Okay, so one point that works, we know, is -6, 0. Okay, so now let's choose a point on this other side. What point do you guys want to choose? Nine, 0, let's see. 1, 2, 3, 4, 5, 6, 7, 8. What?
He's being super nice.
Okay. Yeah, so 9, 0 looks like it would for sure be in the overlapping area. So let's just choose the point 9, 0. We'll go to our first equation, and we would have 0 is less than or equal to the absolute value of 9 minus 2 plus 1. 9 minus 2 is 7. 0, oops. 0 is less than or equal to 7 plus 1, and 0 is less than or equal to 8. And that checks out. We try the other equation. 0 is greater than negative absolute value of 9 minus 1 plus 5. 9 minus 1 is, bless you, 8. So, bless you. 0 is greater than -8 plus 5, and 0 is greater than -3. And again, that checks out. So another point that's the solution is 9, 0. Okay. Any questions so far? No? Okay. Are we ready for number 4? So in this one, it looks like we're going to need 3 colors. Okay, so starting with the first one, y is greater than 1. Where will I go? 1, dash or solid? I did. You might not be able to tell, but this one actually was dashed. Thank you. Okay, will I shade above or below on this one? Good. Oh, and you know what I forgot to do? What should we do back on this graph? Since my point, yeah, highlight the area where they overlap, since we know that it worked in these areas. And then it just stands out, because a lot of these problems, your answer is like the overlapping portion, and so you want to make sure it's very clear as to what part is the overlapping part. Okay. All right, so we have our first graph done. Our second one is, what kind of graph is this? Very good, exponential function. And how do I graph that? So remember, if we were to plug in values, you'd have 0 and 1, and when I plug in 1, I would get 3. So 0, 1, I have a point there, and then right 1, up 1, 2, 3, I have a point. I think we should plug in a couple more points to make sure our graph is accurate. So if I plug in 2, what do I get? 9. Okay, 3 squared is 9. So right 2, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that way I know that my graph is a little bit more accurate. And then this one goes, and it's going to be close to the 0, right? And will this be a solid or a dashed line? Okay, good. So we have this curve, and it gets really close to the 0, remember, but it doesn't actually touch the x-axis. Okay, and less than. So which way do you think I'm going to end up shading for less than on this graph? Below this graph. So the shading would be down here, right? All right, and then our last line we have is y is greater than or equal to negative 2x minus 1. This is a linear, good, it's a linear line. Okay, m equals negative 2, I'm going to put that over 1, and my b value is negative 1. So we go down 1 first to make our point. And then after I do that, we go down 2, right 1, or I could have gone up 2, left 1. And this line will be solid or dash. And this one says greater than, so which way will I shade? Above. Now, do you see the area where all 3 graphs are shaded? So hopefully on yours you can see it better than mine, but it's like this area right here. So we still need to pick 2 points. So let's pick our first point. And what do you guys want to choose? Okay. What? Yeah. Okay, 4, 2. All right, so this is x and y. So my first equation, we have 2 is greater than 1. Does that work? Yes. My second one, we have 2 is less than or equal to 3 to the 4th power. Without even working that out, does it work? Yes. Okay, so that one checks out. Here, 2 is greater than or equal to negative 2 times 4 minus 1. And we probably don't even have to finish working this one out, but negative 2 times negative 4, or negative 2 times 4 is negative 8, and negative 8 minus 1 makes negative 9. And is 2 greater than or equal to negative 9? Yes, so that checks out. So the point 4 comma 2 does work. And again, you have to name 2 points that work for it. For the next one, let's do the point 3, 3. Does that sound okay? So again, x and y are the same values, so it doesn't really matter which one I'm plugging in. And we have 3 is greater than 1. Does that work? Yes. And then I have 3 is less than or equal to 3 to the 3rd power. Does that work? Yes. And then the last one, 3 is greater than or equal to negative 2 times 3 minus 1. And we get negative 6 minus 1, which makes negative 7. And 3 is greater than or equal to negative 7, so that checks out. Okay. Questions? No? All right. We probably don't even need this last one, but we'll do it just for fun. Because math is awesome. All right. And normally I'd have you guys do this one on your own, but for time's sake, we're going to do it together. So here I have y is less than or equal to the absolute value of x minus 2. So actually, I'll have you go ahead and graph these ones by yourself. Okay, and you can continue to graph on your own, and I'm going to graph up here on my own, and hopefully we'll all agree with what's happening. Bless you. Okay, so did you guys get your two graphs? And so my absolute value is less than, so it's shading down. The parabola is greater than, so it's shading up. And so do you see that the overlapping portion is just like right here? And so the easiest points, I believe, to choose on this would be the point of like 0, -3. And then I'm thinking the other point I'm going to end up choosing is going to be exactly. Okay, so we'll go ahead and plug these in over here. So I get -3 is less than or equal to the absolute value of 0 minus 2. 0 minus 2 is -2. That one checks. And then I have -3 is greater than or equal to. I know that 2 times 0 squared is going to be 0. 0 minus 5 is -5. -3 is greater than -5. That checks out. I know the point 0, -3 works. 0, -4. I get -4 is less than or equal to absolute value of 0 minus 4. So we get -4 is less than or equal to -4. Does that work? Yes. If it had just been -4 is less than -4, then it wouldn't have worked. But since it says less than or equal to, we're good.
If we get to -4 on the right side.
That's a great question. I don't know. Just look good. All right, that works too, though, right? Yes. Okay, good. Yeah, why not? Okay, so then we get -4 is greater than or equal to 0 minus 5, which would be -5. -4 is greater than -5. That also checks out. So both points work, and so my second point I'm going to put up here is 0, -4. Any questions? Oh, and then we should go back and highlight this overlapping portion here.
Can you do that on the last one too?
Yes. So highlighting the overlapping portion on number 4 would be in this area. So make sure that you, because you have the purple line here for the 1, and then you have your red, and then your black is like way down here. So it's really those areas where it, okay?